last problem, question 10, you have to optimize the volume of a box. You have this picture. So the first question is to find X for which we have a maximum volume. Then question B, what is the maximum volume, and C, to comment on that. So let's answer A plus B plus C all together. The volume of a cuboid is going to be base times height times width. This is going to be X. And then because you fold it, this is going to be L minus 2x, so it's going to be 250 minus 2x times, and then you have this side, which is going to be 200 minus 2x. So the formula, the function is going to depend on x, is going to be x times 250 minus 2x, 200 minus 2x. You can expand the bracket, that's going to be x times 50,000 is going to be this times this one, that 25 times 2 is 50, and you add 3 zeros, 50,000 minus 500x minus 400x plus this times this one, 4x squared. That's going to be 50,000x minus 900x squared plus 4x cubed. So let me write it the other way around, 4x cubed minus 900x squared plus 50,000x. You work out with the derivative. The first derivative is going to be 12x squared minus 1,800x plus 50,000, and you take this equal to 0. You solve the quadratic equation, and by a numerical package, you can find that x1, the first root, is 147, x2 is 2.8. Then you can use the second derivative test. So second derivative of this function is going to be 24x minus 1,800, and then you evaluate for this x1 and x2. That is going to give you 24 times 147 minus 1,800. That's going to be 1,728, which is positive. So you have a minimum value here. So we don't want this this option. And then you evaluate at 2.8. It's going to be 24 times 2.8 minus 1,800, and that's going to be a negative value. So that's going to give you maximum volume. So the appropriate choice for X is going to be 2.8. And then for B, you plug in 2.8 into the formula. So it's going to be 2.8 times 250 minus 2 times 2.8, 5.6, times 200 minus 2 times 2.8, 5.6. And that is roughly 133,000 millimeter cube. You can turn this into meter cubed, so it's going to be 133,000 times 10 to the power of minus 6. 10 to the power of minus 3 meters. And that is going to be to the power of 3. That's going to be 10 to the power of minus 9 cubic meters. This is going to be the following. So it's 1, 2, 3, 4, 5, 6, 0.000133000 cubic meters. So the maximum volume is gonna be 133,000 millimeter cubed, or 0.000133000 meter cubed. And see, we obtained two values for x 147, x 2.8. This one has been rejected because it gives us a minimum, and this one is being accepted because with the second derivative test is negative, so it's convex downwards, so it will give us a maximum point. So that's why we choose this one by employing the second derivative test.